Hello, and welcome to Lesson 9 of the Big Data and Hadoop Developer course offered by Simplilearn. This lesson will focus on Pig, which is the analytics component of the Hadoop ecosystem. What you will learn in this class. After completing the lesson, you should be able to first explain the concepts of Pig, understand the types of data models and data types supported by Pig, differentiate Pig and SQL. We will go over the similarities and the differences between the two. Understand the functionality required to operate with the Pig scripting language. And finally, you should be familiar with basic Pig commands. Prior to 2006, there was only one option to develop MapReduce programs on Hadoop, and that was using Java programming language. While MapReduce with Java is quite powerful, it's not very easy to work with. Developers had to be mindful of MapReduce specifics like map, sort, shuffle, and reduce. Even simple operations like joining and filtering required quite a lot of code. Finally, developers had to be mindful of the complex data flow where the output of one task can be used as the input to another task. To overcome all these complexities, Pig was developed in late 2006 by the people at Yahoo. It later became an Apache open source project. So basically, Pig is another language besides Java to write MapReduce programs. So what is Pig? Let's define it first. Pig is a scripting platform that runs on Hadoop clusters designed to process and analyze large data sets. The features that make Pig very popular with developers are its extensibility, self-optimizing feature, and the ease of programming. First, you obviously don't need to know Java in order to write Pig scripts. Pig can work with both structured and unstructured data, and it uses HDFS both as a data source and as the destination to store the results of the analysis. And finally, Pig includes a number of self-optimization features, which we will shortly cover in greater detail. So let's look at an example to understand in what circumstances Pig would be most useful. So in our example, data scientists use grid tools to scan through petabytes of data. They write scripts to test theories or to gain deeper insights. But the challenge is that in the data factory, the data may not be uniform and may not be standardized. It can be structured or semi-structured. The schemas may only be partially known or unknown. And with this set of circumstances, these are all the challenges that are addressed by pigletting language. And this is what makes Pig a good solution for this sort of challenges. Let's look at the components of Pig. The two major components are First, the pig-letting scripting language, and second, the runtime engine. The scripting language is basically a procedural data flow engine, and it has a simple and intuitive syntax and commands that are applied to implement business logic. For example, command as simple as load and store. The runtime engine, on the other hand, it's basically a compiler that converts Pig scripts into MapReduce jobs that are then submitted to Hadoop, and the results can be stored in HDFS. So the Pig interacts with Hadoop with both of its components, the HDFS and the MapReduce. Pig operations can be broken down into three major stages. First stage consists of writing the script and submitting it. In this example, it's a simple script that filters our data and returns a summary grouped by a field. The first line of the command is the load command, which defines our data source. The second stage of processing happens in the execution engine, where the script is parsed, validated, checked for errors. Optimizations are performed at this stage, and as a result of those optimizations, execution plans are generated. Now then, according to those execution plans, the MapReduce jobs are created and submitted for execution. While the execution is in progress, the engine continues to monitor those jobs. And the final stage of the execution would be the actual execution of the plan and returning the results. And those results can be either returned to the screen or they can be written to HDFS. Next, we'll look at a few salient features of Pig that make it so popular with developers. First one is step-by-step procedural control. Many programmers find this step-by-step procedural mode more intuitive and easier to work with than SQL. Second one is how Pig approaches the schemas. Schemas are, first of all, optional, and second, they can be assigned dynamically. So developers are not required to have a complete understanding of their entire schemas. And finally, Pig offers support for many data types, some of them very complex and very flexible, and it offers support for user-defined functions. Next, we'll look at the data types supported by Pig. There are four basic data types. First is atom, and that can be any atomic value, can be of any data type, can be long, double, string, integer, as long as it's an atomic data type. Second one is a tuple. So tuples can also be of any data type, the elements within a tuple. Third one is a bag, and that's basically a collection of tuples. And nice thing about it is that those tuples within the bag, they don't have to be uniform. They can have elements of different data types, and the number of elements can also vary for each tuple. And the last data type is map, which is basically an associative array. The array itself must be of character data type, but the elements within the array can be of any type. So those are the four data types supported by Pig. Now, how does the engine recognize and interpret data types? There are several ways. First, they can be explicitly defined either in the schema or in the S clause of the script. So you can explicitly tell the engine what the data types are. But it can also infer the data types, and it can base it on several things. One would be the return type of a user-defined function, and the other one could be based on the operation that you are trying to perform. For example, if you are performing a numeric operation, Pig will assume that the data types are numeric. Another important point is that type conversion is lazy, which means that the evaluation does not happen until the execution stage. Now, if we do not declare a data type, and if Pig has no way to infer the data type, it will by default assume a byte array. Another important point about Pig data model is that it is fully nestable, which means that one type can be nested within the other, as we've seen with complex types like bags or lists. And this offers a lot of flexibility, and it's natural and more intuitive to programmers. And another important benefit of this flexibility is that in a single data source, you can combine records of many different types, and that means you can avoid expensive joins because all of your data lives in a single file, single source. There are two execution modes available with Pig. The local mode, the script runs on your local machine. And in MapReduce mode, the script will be interpreted and it will be transformed into a set of MapReduce jobs, which will be then submitted for execution. And that's the mode you will be most often operating with, the MapReduce mode. Interactivity. In the interactive mode, you can submit Pig commands one line at a time, and they will be executed as they are submitted. In the batch mode, you create a script and then submit the entire script for execution. Again, this is the batch mode is the most common mode for executing Pig. Next, let's compare Pig and SQL. There are some similarities, but there are some important differences as well. While SQL is a query language that is intended to interact with relational databases, Pig is really a scripting language that is designed to interact with HDFS. SQL queries are executed as a single block, while with Pig uses a procedural step-by-step style. Evaluation with SQL, the evaluation is immediate. You need to understand your entire structure before optimizer can come up with the execution plan. While Pig uses lazy execution, and it does not happen until the execution step. Pipelines are supported in Pig. In SQL, it's quite difficult to create intermediate results, while in Pig this is natural, and it's something used quite often. Next, let's look at examples of SQL query and equivalent Pig script. So in our example, we're looking at two data sources, sales and customers. In the case of SQL, those are our database tables, and in case of Pig, those are files on HDFS. So our task is to join the two tables, and then to return the summary of amounts by customer. We apply filters by city, and the final results are also filtered as well based on the aggregated summary. And finally, the output is sorted. So when we look at Pig, the first two lines execute the load command. That is where we define our two data sources. One is the customer file, and the other one is the sales file. In the S clause, we define the data elements in each source. We apply a filter by city. We execute the join between the two files. We execute a group by command. And finally, we generate the summary of amounts for each customer grouping. Now, note that while in the SQL query, we use the having clause to filter the output. In Pig, we're using another filter. So we're using a filter first to filter by city, and then after generating our summaries, we're using another filter to filter out those summaries. And we're using the order command to sort our output, and the dump command to return the results to the screen. In this case, we are outputting to the screen instead of writing data to HDFS, which would be another option. One important stylistic difference to keep in mind here. As we mentioned before, SQL is a query language, while Pig is a procedural step-by-step style. With SQL, you basically define the result set that you want returned, and it is the job of the optimizer to figure out how best to return the data and what operations to execute. With Pig, on the other hand, we are explicitly stating the operations that we want performed. Now, Where can you get some sample data for Pig development? Well, lots of places, few examples here. You can use a book library. You can use Wikipedia database, public data available in the Amazon cloud. Another good source would be the national climate data at NCDC. So next we'll look at specific Pig commands and operations. First, we'll look at loading and storing data. Loading refers to loading relations from the files to the Pig buffer. And this is done with the load keyword. If you recall, in the example of the script that we just looked at, we executed two load commands, one for the customer file and the other one for the sales file. Store command is used to store the output of our analysis to HDFS. Another alternative would be to use the dump command to return data to the screen. So with the store command, it typically will be followed by the directory where you want to write the data to on the HDFS. Next, let's look at how Pig script is being interpreted by the engine. So the 4 steps are, first, syntax is validated, semantics are validated, error check is executed. Second step, type check with schema is performed. Third, references are validated. And finally, the statement is executed. The diagram on the right shows a few points where optimization is performed. Note that there are several steps along the way where optimization is performed, and as the result, the execution plan is submitted. Before MapReduce jobs are generated and after. Next, we'll look at relations performed by developers working with Pig scripts. First, we'll list them, and next, we'll examine each one of them in detail. So those operations are filtering, transforming, grouping, sorting, and combining. In the next few slides, we'll look closely at each of them. Transforming. That refers to operations similar to the transformations that you perform in SQL. Could be appending the strings together or splitting them or any other common data transformation. Filtering, that's pretty self-explanatory. That refers to disregarding the certain records based on a condition. Grouping, again, similar to SQL's group by clause. Basically, we are compressing the data based on a specified set of columns. Sorting, similar to SQL's order by clause, performed with the order command in Pig. Combining. Now, combining is executed with the union keyword, and it is similar to SQL's union all command. Note that unlike a union command in SQL, combining does not filter out the duplicates. It will just append the two data sets. So combining is similar to union all in SQL. And splitting, which is basically opposite to combining. You perform splitting when you want to partition your data. Next, we'll go over several Pig commands. Load, which we already looked at, refers to loading data from the file system. Store writes data to HDFS. Another option would be dump, where you would write the output to screen. For each, applies the expression to each record. Now, note that the output of for each can be one or more records. Filter, a command to disregard certain rows based on a condition. Group or co-group, the command you use to compress the data based on the specified set of columns. Join joins two or more sets based on a shared key. Order performs a sort based on the specified key. Distinct removes duplicate records. Union appends two data sets without removing duplicates. Split, the opposite of the union, it partitions your data set. Stream, now that allows you to direct the output of a Pig script to any other program that you have defined. And limit limits the number of records to return. So, takeaways. Let's go over the key points that we have learned in this class. Pig is a high-level data flow scripting language and has two major components, runtime engine and Pig Latin language. So the Pig Latin language, that's your interface with the runtime engine which executes the script. Pig runs in two execution modes, local and MapReduce. Local mode runs on your local machine, while in MapReduce mode, a Pig script is converted to MapReduce jobs that are then submitted to Hadoop. This is the mode you will most often be working with. Pig Engine can be installed by downloading the mirror web link from the apache.org website. So it's pig.apache.org. That's where you can download the Pig Engine. 3 parameters need to be followed before setting the environment for Pig Latin. Now, first, ensure that all Hadoop services are running properly. So your cluster has to be up and running. Second, make sure Pig is completely installed and configured. And third, all required data sets should be uploaded to HDFS to make sure that the load command will find your data sources.